Now, what this plasma is? Plasma is actually known as the fourth state of the matter we have. This is the fourth state of the matter. The fourth and fifth state of the matter is developed later after studying the characteristic of solid, liquid and gases, but they do not have any link with solid, liquid and gases. Plasma, we have seen that plasma is basically formed when you remove an electron from an atom. You know that any atom will possess a nucleus in its center and the electrons revolving around in its outermost orbit. When you remove an electron from any nuclei or any structure of the atom, what will it do? The free electron will have a tendency to conduct electricity. So this point is very important, that only free electrons in an atom have a tendency to conduct the electricity. So some of the particles in the nature are having a tendency to conduct electricity just because they are possessing the free electrons in the nature. So these will be the property which is basically utilized in the plasma. So plasma is our fourth state of the matter, which is produced by the ionization of the gases. Now you can see that stars are shining because they have a small amount of plasma in them. And you have also heard about the neon lamps, you have seen about the fluorescent lights. These also have a neon light bulbs, have a neon gas in them. Fluorescent light will have a helium gas in them. So these all are shining just because of the plasma that is present in between them, and these are formed by the ionization of the gases only. Now let us take a general example as a TV screens in our houses. You can see that the plasma TV we are aware about nowadays, these will contain the two structure. It means the two layers of the TV, that is the screens, will have a deposition of plasma between them. So whenever you switch on the supply, you can see that you will get exactly three colors, that is the red, green and blue. These are actually the red, green and blue phosphors which are eliminated by the plasma, and you can see a variety of colors on the TV screen, and these colors are obtained on the screen basically due to the intermixing of these three colors, that is the red, green and blue one. So this is the effect we can analyze and it is known as plasma. So it is the fourth state of the matter we have. So let's learn some of the important points regarding plasma. So what is plasma? Plasma is our fourth state of matter. This is our fourth state of matter. And what basically it consists of? It usually consists of super energetic and super excited particles. So we can say that it is going to constitute super energetic and super excited particles. It is formed by ionization of gases. It is usually formed by ionization of the gases, and the examples we can see here are first one is neon sign lamps, and second one is fluorescent lamps or lights. Now this neon sign lamps basically consist of a neon gas. It is having a neon gas, and in case of the fluorescent lamps we have a helium gas. So this is very important to learn that which gases they are possessing. So they will have a constituent of neon and helium gas we have. Now apart from this, we have seen that when any atom or nuclei will lose an electron, the gas will be ionized, and this ionization of a gases will lead to the conduction of electricity. So they will easily conduct electricity, and one more feature of that this plasma is that it is having a very characteristic color. It means depending upon the nature of the gas, which color is plasma is secreting will depend upon the nature of the gas. So we can also write that color of the plasma will depend upon the nature of gas. The color of the plasma will depend upon the nature of the gas. Now, let us understand the plasma with the help of a diagram here. Suppose we are having a gases here. Now, if we are going to ionize these gases, what we have to do? We have to just take an electron from its atom. Now, if we are having the gases here, so suppose we have an atom here and in the center we are having a nucleus, and you can assume that an electron is revolving here. Electron is revolving in that part and nucleus is situated at the center. Now, if you are removing this electron from an atom, this is our atom and again it is having a nucleus in the center and we have removed the electron from the atom. We are writing it, we are removing an electron. Now, this atom will become neutral, but plasma are actually the neutral particles, but because they are having an equal amount of positive and negative charge. So, if the electron is removed, it will become a neutral particle. So, we can say that the plasma will become neutral, or anything is said to be neutral when it contains equal amount of positive and negative charge. Equal amount of positive and negative charge. But if this is the electron, after removing the electron we will get the neutral atom here. Suppose this is an atom of the gases we have. Now, if we are going to ionize these gases, suppose the gases are ionized. If these gases are ionized, the gas particle will achieve a higher excitation level. This will achieve a higher excitation level because if I am ionizing the gases, you can see here that these are our two states. This state is known as the low energy state. And this state is our high energy state. This is our low energy state, this is our high energy state. You can see that when you are going to ionize the gases, the particle will jump from low to high. It means the particle here present will go to this state. The particle will be present here. Now, if the particle jumps from higher energy state to the lower energy state, it will definitely going to emit a photon. Suppose this particle is coming from high to low energy state, it will going to give you a photon. And photon are the particles which are having a light in them. It means they will eliminate a light. So, if any particle jumps from high to low energy state, there will be a elimination of photon. So, the photon will be eliminated and this photon will going to give you a constituent color of the plasma we have. So, similarly, when the ionization of the gases is done, it means by supplying electrical supply, we are supplying here electric supply. By supplying electricity, we are having a ionization of a gases, and when ionized, they will going to produce a super energetic or the super excited particles, and after the ionization of the gases, we will receive a compound that is known as plasma. Now, its application is basically found in sun and stars. The sun and stars are shining because you can assume a ball of plasma is present in between them. So, these are shining, they are emitting the light just because of the plasma. So, the application of plasma we have here is if we are talking about the applications of plasma, so we can write here the sun and stars are shining because of the plasma. Sun and stars have plasma in them. So one application you have seen here, that in the neon sign lamps and the fluorescent lamp, that is the neon and the helium gases are used. These are the example of the plasma we have. Second application is about the sun and stars. Sun and stars will constitute a plasma in them, that just because of the having plasma, they are going to give you a light. Next application is very recent nowadays, that is in TV screens. In TV screens nowadays we are using a plasma TV. It means in between the glass layers a plasma is filled, and that plasma is able to give you three colors: red, green and blue. These three colors will going to be obtained when a plasma is filled between the two glass layers. Now when you switch on the electric supply, these colors will going to intermix with each other, and you can see that you can observe a variety of colors on the screen of the TV. Now what actually these colors are? These colors are the combination of that red, green and blue one. So this is all about the plasma we have dealt here, and the plasma is having a variety of applications in our day-to-day life, and it is considered as a fourth state of matter. Now we are left with the last state of the matter we have, that is about the BEC. BEC means Bose-Einstein condensate. So firstly copy it from here, so we can proceed to our next state of matter. So now let's move to the next state of the matter we have, and the next state of the matter we have is BEC. Now this BEC is the Bose-Einstein condensate, and sometimes it is also known as the fifth state of the matter. Now the credit for the development of the fifth state of the matter goes to Satyendranath Bose and Albert Einstein, because these two work on the fifth state of the matter, and basically this type of a matter is important for quantum physics point of view. It means these are actually the quantum particles we have. So the first point regarding Bose-Einstein condensate is that it is known as fifth state of matter. Next term we have, it is discovered by Satyendranath Bose and Albert Einstein. Now what actually this BEC, that is the Bose-Einstein condensate is? This gas, it means this kind of the particles are obtained by heating the gases at a very low pressure. It means absolute temperature is whenever achieved, we will get a particles that is having a very low density. These are very low extreme particles. So These are termed as the Bose-Einstein condensate. So by cooling the gases, we can achieve the fifth state of the matter we have. So these are the particles are obtained by cooling a gas at extremely low pressure, and the pressure here is used about 100,000 the pressure of the normal air or the density of the normal air we have. So which criteria or the which conditions we are using here? So for obtaining the fifth state of the matter, the density is about 100,000, not 1000, it is 1000. It means it is in a very decimal point, it means number of zeros will occur between them. 100,000 the density of normal air. So its density is kept too much low that by compressing the gases, by cooling the gases, we can achieve the fifth state of the matter we have. So this is about the fifth state of the matter. It is obtained by cooling a gas at a very extreme conditions of temperature and pressure, and we will achieve it by keeping the density very low as compared to the normal air. Now in obtaining the fifth state of the matter, the absolute temperature is used. Absolute temperature will be, it means 0 degree Celsius or 273 Kelvin. It means extremely low temperature and pressure conditions are usually used to achieve the condensate form of a matter. Now this is not only the simple form of the matter we have, this collapses to give you the quantum particles. It means BEC cannot be compared with solid, liquid and gas that we have discussed, because this is not a simple form of the particle. It is collapsed to give you a form that are known as the quantum particles, which is having a particular wave function. So next point will be these are not simple particles, but they collapses to form quantum particles. It means it has found its application in the quantum physics. And due to the invention of this fifth state of the matter, the Albert Einstein and the Satyendranath Bose will achieve a Nobel Prize, because they are the persons who only give a significant idea or approximate idea about the fifth state of the matter we have. So you have seen that in our today's lecture, we have discussed about the characteristics of all the 5 states of the matter, and you are aware about the 2 new terms, that is plasma and BEC, that how they are applicable in our day-to-day life. So this lecture is over for today. Thank you so much and have a nice day.